The tools needed to isolation test the external voltage regulator Denso internal fan alternator charging systems are an inexpensive battery load tester, a homemade bank of resistors. This test tool is composed of 4 50 ohm resistors wired in parallel with an alligator clip on each end. These are ballast type resistors available at most hardware stores or any Radio Shack. Place the positive lead of the battery load tester on the battery output terminal of the alternator. Place the negative lead of the battery load tester on a good ground on the body or frame of the alternator. Throw the load switch. Readings under 9 volts should be considered a defective bus fuse or a partially defective fusible link. Remove or unplug the small wiring harness portion from the alternator, but leave the battery post hooked up. Here we have an ordinary jumper wire with alligator clips at either end. Attach one of the alligator clips to one of the field terminals and the other side to ground. This is a short piece of 12 wire with a 1/4 inch eyelet crimped on one end and stripped on the other end. The nut is an M6 by 1.0. The number 12 wire is attached to the alternator battery output post without removing the wire that's already installed. Then the resistor bank is clipped to one side of the wire. The other alligator clip for the resistor bank is clipped to the other field post. This is a desirable amount of amperage flow because it allows the technician to diagnose a common failure with Denso externally regulated alternators. And that is a partial brush failure at low RPMs and low field current duty cycle. Scanners and full field bypass tests cause 7 amp field currents, which are strong enough to jump the gap and delusion the technician into passing the alternator. Lower field currents caused by the resistor simulate operating conditions, which will detect resistance from a failing or fouled brush when observing the amperage output of the alternator. The round plug is the same basic idea and schematic. It just uses 2 female spades instead of the 2 post terminals. You can use either one reversibly. Here you can see it's designed in the same manner as the other style. The red wire comes out of the battery terminal, goes through one side of the resistor, then through the resistor and down into the 1 spade terminal, which is a field terminal. Then it comes back out the other side and goes to ground. Same exact idea with the pin style terminals. Just use each individual pin as if it were the post or the spades. Just like the post or the spades, you can see the red wire comes off the battery post, which is hot, goes through one side of the resistor bank, comes out the other side of the resistor bank, goes into the 1 pin. Then it comes back out and goes to ground. Clip the inductive amp probe over the wire as close to the alternator as possible and zero it in. We're not testing the alternator for amperage output during this test. What we want to see is a steady amperage output when a constant RPM is applied. Observe the amperage at an idle. Any minor drop-offs or fluctuations should be considered a defective or fouled brush. Then observe the amperage at 2000 RPMs. Any bouncing of amperage flow should be considered problematic. This alternator passes the test. The amperage is steady and even at all times. Be careful not to get burnt when you remove the resistors from the test period. They will be hot.